In this video, we are going to cover some geometry vocabulary. These are the notes VL-1301. Let's get started. So we have 1, 2, 3, 4, 5, 6, 7, 8 terms we're going to cover. I want to show you like some little markings that kind of denote or show what those like will show you when something is like parallel or congruent. So let's get started first. Let's choose red, it stands out a bit more. The first term is parallel. Parallel is they are two lines that will never intersect or touch. So whenever we have lines that are parallel, they don't touch each other. And whenever you see parallel lines, oftentimes you'll see like this little arrow thing. Now it could go up, or actually it could also go down. It kind of doesn't matter. But basically, when you see that, it means that the two lines are parallel. They're never going to touch, even if you took these lines and you kind of extended them like forever in both directions. They will never, ever touch. I'll give you an example of lines that aren't parallel. Like this line and this line, you can't say that this line is parallel to this line. Because if I kept drawing this line out and I kept drawing that line out, they'll eventually touch each other. So those two lines would not be considered parallel. Over here, this is, we have two sets of parallel lines. So we consider this 4 different lines because lines are straight. You don't consider this one line that bends and goes around. It's 4 lines that form a quadrilateral or a parallelogram in this case. And we would say, oh, this is parallel to that. So we would say AB, line AB, is parallel to line DC or CD. Both kind of mean the same thing. Sorry, hopefully that doesn't look like an O. Should look like AD. Let's try that again. DC. So line AB is parallel to DC. And we also have another set of parallel lines, but we don't want to just put one arrow like this, one arrowhead, because that just means like when you have one arrowhead, it means like, oh, this is parallel to this, and which is also parallel to that and that, which is not true. So if you have a second pair of parallel lines, you would have to put a, on the same figure, you would put 2 arrowheads like this. And we would say AD, or DA, let's call it AD, is parallel to line segment BC. So there it is. You have one pair of parallel lines and then another pair of parallel lines. Let's take a look at the word congruent. Congruent just means equal in size or length, and I know that's hard to see, but it's basically an equal sign with a like a little squiggly above it. There we go. And so congruent. So we have a rectangle here, and rectangles have 2 pairs of congruent sides. So this is congruent to that. And how do you know? So whenever you see a line, a single line, I'll call it a notch, that means this notch, EF. So EF is congruent to F. EF is congruent to GH. All right, so congruent to G and H. We also have another pair of congruent lines, the side lines. This right here, EG, is congruent to FH. So to denote that that is also congruent, we're going to have to use a pair, because that means this is congruent to that, but these two are congruent to each other. If we had something like a square, so for example, if we had a square, all the sides of the square are equal. So what we can say is like, oh, this is congruent to that, which is also congruent to that, which is congruent to that. So all 4 sides are congruent. So you would see that on like a square, is that all sides are equal. In this case, we have another pair of congruent sides, which is EG is congruent to FH. There it is. All right, next term, we've got the term right angle, which is a 90-degree angle. 90-degree angles are very important, like geometry in life. So you'd say, to draw a little right angle, it's like a little square. Or, I mean, you don't really need to draw the full square. I can just draw the two sides of the square. Now, typically, this is two 90-degree angles. You don't really have to do like two of them like that. You just can do one. And you can usually assume the other side is also a 90-degree angle. But this also has a 90-degree angle. I'm not doing a very good job drawing straight lines, but it's okay. This is called a right triangle because it's got one 90-degree angle. And this is a rectangle, which has four 90-degree angles. Let's take a look. Diagonals. Diagonals are lines inside of a shape that connect one corner to another corner. So what is a diagonal? A diagonal would be this. That's a diagonal. This right here is also a diagonal. One corner to the opposite corner. Yeah, you wouldn't say like, oh yeah, that and that corner. No, opposite corner means that corner and this corner. So those would be diagonals. Let's talk about the word length. Length is the distance from one point to another point measured in units. What do I mean by units? Units like inches or feet or miles or centimeters or meters or kilometers, or U stands for units. When would you say units? Units is almost like if it doesn't say that something is in feet or inches or miles or meters, you would say, oh, it would be in units. So width and height are also considered different kinds of length. So length is almost like a broad umbrella term, and width and height are kinds of length. So this one, let's see. The length between J and M, so they want the length from J to M, would be from here to here. What is the length from J to M? Well, you've got one segment right here. I don't know if that's a centimeter or feet or a foot or inch. So I would say that's one unit right there, and then another unit, and then another unit. So that is 3 units, right? 1, 2, 3, 3 units. 3 units. So that is J and M are 3 units. Or you can just say 3U. And the length of M and L, that is the length from here to here. What is that? 1, 2, 3, 4, 5. That is 5 units. So we'd say 5 units, or if just 5U. U is fine. Perimeter. Perimeter is the distance around a shape. So length is just, it's any amount of distance. Perimeter is like the distance around a whole shape specifically. So perimeter is measured in units as well, like in inches, feet, miles, centimeters, meters, kilometers, and units. I don't know how long these are, so we'll just call them units. So the perimeter of this shape is, well, let's see. This is 3. Actually, I should probably say 3 on the side and like 5 down there as well. This is 3, and this is 5. And you can't say that the perimeter is just 8 because you're adding 3 and 5, because we also need to add the top and the bottom. So really, I want to find the perimeter of the whole thing. I don't like how I did that. There we go. That's perimeter. Oof, why am I doing such an ugly job of this? Sorry, I know you're watching this video and you're like, oh my gosh, I don't care. I get what you're getting at. Okay, so that's 3, that's 5. This is also 3, and this is also 5. So that is a perimeter of 13. 16, I'm sorry. 5 plus 5 plus 3 plus 3 is 16. So you see 3 plus 3 plus 5 plus 5 equals 16. 16 what? 16 feet, inches, centimeters, 16 units. Because I don't quite know how long, what unit that is. Finally, 2 more terms. Our last 2 terms are area and polygon. So area is the amount of flat space inside a shape. Area is measured using square units like inches squared, feet squared, mile square, centimeter square, meter squared, kilometer square, and unit square. So notice I measure length using just the line segment, like this line. This is 1 unit, 2 units, 3 units, 4 units, 5 units. I can measure it using something flat. When I measure area, I have to measure it in squares, because I can't just use like, oh, how many like inches or how many units is this? It's like, well, the units are squared, so we call them square units. So this is an example of 1 square unit right here. This is 1 square unit. There it is. And we call it a square unit because it makes a square, obviously, and each side is 1 unit long. So how many square units is this? Well, let's take a look. If it's 3 on the side, well, I could just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is 15 square units. Now, we can say square units or we can also say, and this is actually going to be more common, 15 units squared. And squared is like this little number 2. It's like an exponent number 2. And if I wanted to use u squared, I can do that too. Or just 15u squared. Now, how many square units is this? It's 1, 2, 3, 4, 5, 6, 7, 8. And then you have a bunch of like these like partial ones. So we're actually going to learn how to find the area of this later. But for right now, you can see that we can find the square units. Some of you may have remembered that you can actually just find the area by multiplying the sides. So the top side is 5, this length is 5, and this length is 3. If we multiply this length with this length, you get 15, which is the same thing as counting. It's just a faster way of getting to your answer. Lastly is polygon. Polygon is a 2-dimensional flat shape with 3 or more sides. So what is a polygon? It is any shape with more than 2 sides. So this is a polygon. Actually, I should probably, and then, let's go from here to here. That's a polygon. 3 or more sides. So I can do this, and then this, and then this, and then this, and then I can even go like this, and like, whoops, that last one was not good. And finally like that. These are both polygons. You just have to have 3 or more sides to be a polygon. And that's it. That is our vocabulary. Some common before we do, common polygons are like triangles. We've also got like rectangles and squares and parallelograms, trapezoids, octagons, all of those things. But you can also get pretty wacky, like, this shape right here. So that's it for this set of notes. Go ahead and try some problems involving definitions.